So welcome to the fourth tutorial. In the last one, we studied about how to address a particular register or any memory location in 8051. Now we will study about the instruction set related to it. Primarily, this instruction set is divided into 5 parts. The first one being the data transfer, the second is the arithmetic, third logical, fourth one is the Boolean variable manipulation, and the last one is the program branching. Let us study one by one. In this tutorial, I will be talking only about the data transfer instructions, and the next ones will be dealt in the next tutorials. So the first classification is the data transfer instructions. The term data transfer instructions simply implies that from where the data is being moved or from where the data is being taken. So there will be two necessities here, that is the first one being the destination and the second one being the source. Now take a look at the syntax of this instruction. For any instruction, remember that the first location will be that of the destination and the second one will be that of the source. Now there are various instructions related to the data transfer. Let us study them one by one. In the first case, move a rn. This means that the data from the rn registers, that is from r0 to r7, will be moved into that of the accumulator. Now in move a direct, it moves the data from the direct byte, that is from the direct memory location, into the accumulator. Now move a @ri. Remember the indirect addressing mode. In this case, the data in ri will be the location from where data is to be needed, and that data is moved to the accumulator. Move a hash data. In this case, the hash sign represents the immediate addressing mode, and the data is the immediate data which is to be moved into the accumulator. Now in this case, the syntax is just reverse, that is the destination is placed here and the source is placed here. Thus it is moved from accumulator to rn. In this instruction, the data from the direct memory location is moved into rn. Rn consists of registers from r0 to r7. In this case, the immediate addressing mode is used, thus the immediate data is moved into the register rn, that is r0 to r7. In this case, move direct a. It means that the data is moved from accumulator to the direct memory location. In move direct rn, the data is moved from rn registers to the direct memory location which is specified. Now this instruction moves the data from direct memory location into another direct memory location, that is from direct to direct. That's why it is move direct direct. In move direct @ri, in this case again implies the indirect addressing mode. In this case, the data present in ri represents the memory location from where the data needs to be moved. In this case, ri can only be r1 and r0, and this data is moved into direct memory location. Now in move direct hash data, the immediate data is taken and it is moved directly into the address or the location. Here the data from the accumulator is taken to the indirect memory location pointed by ri, that is r0 and r1. In this case, the direct data is moved into the indirect memory location. In this move ri hash data, the immediate data is moved into the memory location pointed by ri. Now sometimes we need to address the 16-bit address, but for the 16-bit addresses, all the above instructions become invalid because they hold only 8-bit address. For this purpose, we use the data pointer. The data pointer has the capability of holding a 16-bit address, and in this case, the 16-bit address is loaded directly into the data pointer. This instruction is specifically used for moving the data into the or from the external memory location, that is from the 64 KB RAM. Now these next two instructions, that is move a @a plus dptr and move c a @a plus pc. These both instructions are used when the code bit relative to the dptr or pc need to be moved into accumulator. Now what is a code byte? The code byte is something which accesses the code bytes from the lookup table. These lookup tables may contain the square roots or any other information like the ASCII or any other data which is more oftenly used. So in this case, these two instructions can be used. Now take a look at this instruction, move x a comma @ri. Now as soon as x is appended to move, it means that we have to access the external RAM. In this case, this instruction might look similar to move a comma @ri. Well, it is, but the only difference is that here @ri, that is the register R1 and R0, can contain data more than 128 bytes. Thus, in this case, more than 128 bytes of address can be accessed. Now the next instruction is move x a comma @dptr. Now this instruction is exactly similar as the upper instruction, but the only difference is that here the external 16-bit address can be accessed. In the first we could access only till 8 bits, but here we can access 16-bit locations, 16-bit memory locations. Now the next two instructions are very similar as compared to the above instructions, just the source and the destination are altered. That's it. Now let's move on to the next type of instructions, that is the exchange instructions. These instructions basically exchange the data from one location to the other. In exchange a comma rn, the data from rn, that is either from r0 to r7 registers, are exchanged with the data of the accumulator. In the second case, that is exchange a comma direct, the data stored at a direct location is exchanged with the contents of the accumulator. And again in this case, symbol, that is again the indirect addressing mode. In this case, the data from the location mentioned in the register R0 or R1 is exchanged with the contents of the accumulator. Yep, that's it for today, guys. In the next tutorial, I will be talking about the stack and the push and the pop instructions related to it. And after explaining the stack, I will move on to the remaining instruction set. I hope you loved this video. Please like, share and subscribe it. Thank you.